Hello students, welcome to the lecture number 3 of chapter 6. In lecture number 2, we have discussed about 4 basic types of angles like adjacent angles, linear pair angles, complementary angles and supplementary angles. And in this lecture, we will discuss about another type of angle whose name is vertical opposite angles. Okay, so our today's topic is vertical opposite angles. Right? You can see there are two terms. One is vertical, another is opposite. Okay, the word vertical comes from a word vertex. So here the two angles must have a common vertex. Understood? And the second word is opposite. It means the two angles must be opposite to each other. Opposite means what? If one angle faces towards left, then another angle must faces towards right. If one angle faces towards top, then the other angle should faces towards down. These are the opposite angles. So for simple understanding, you can remember like this. If two angles have a common vertex and if the two angles are opposite to each other, then they are known as vertical opposite angles. Understood? This is a simple definition. Now we will discuss about the exact definition of vertical opposite angles. So what are the exact definition? So the exact definition is two angles are said to be vertical opposite angles if they follow two conditions. Okay. So in order to be vertical opposite angles, the two angles must follow two conditions. Then what are the two conditions? The first condition is the two angles must have a common vertex. Okay. See, suppose this is a point and from this point two rays are originated. OA and OB. It means they will form an angle in between them. Okay, but we are talking about two angles, not single angle. Two angles. If the two angles have common vertex. Okay, so let us draw another angle. See, this is C, this is D, and this is O. Now you can see from this point, from this origin, two another rays are also originated, OC and OD. That means they also form an angle in between them. Now compare these two angles. These two angles have a common vertex, O. Understood? So if you consider the angle AOB, and the angle COD, right? So for AOB angle the vertex is O. For COD angle the vertex is O. So the first condition is if two angles, okay, have a common vertex. Right? Now coming to the second condition. The second condition is that if the two arms, these are the two arms of one angle form two straight line with the another two arm of second angle. Again let me remind you, these are the two rays and known as arms. So the second condition is given that if two arms of one angle form straight line with another two arm of the second angle. See, this is the arm OA, right? And this is the arm OB. Okay, these two arms are for the angle AOB. Simply for the angle COD. Right, OD is an arm and OC is another arm. Now you can see the arm OA of the angle AOB makes a straight line with another arm OD. The ray OA or the arm OA makes a straight line with arm OD. Yes or no? Yes. This is a straight line or not? Yes, this is a straight line. Okay, similarly, the another arm OB of the angle AOB make another straight line with the arm OC of the second angle COD. Okay, so here OA and OD forms a straight line. Similarly, OB and OC form another straight line. Okay, so this is the second condition which tells you that if two arms of one angle form two straight lines, These are the two straight lines with another two arms of the second angle. Then these two angles are known as vertical opposite angles. Understood? So the first condition, again I am telling you, the first condition is that the two angles must have a common vertex, that is O. The second condition is that the ray OA form a straight line with OD and the ray OB form a straight line with OC. This is the second condition, and these two conditions must be satisfied in order to be vertically opposite angles. So you can say now the angle AOB and angle COD are vertically opposite angles. Okay, so write angle AOB and angle COD are vertically or vertical opposite angles, or you can write in short form VOA, vertical opposite angles, right? See, this angle faces towards this direction and this angle faces towards this direction, so they are opposite and they have a common vertex, right? So in order to be vertical opposite angles, you need the two angles must have a common vertex and the other two arms must form two straight lines with the another two arm of the second angle. Okay, so this is the concept of vertically opposite angles. Now you see, whenever two straight lines, okay, cross each other like this, how many angles are formed actually? Actually, how many angles are formed here? One. Suppose this is angle 1, or you can take it theta 1. This is also another angle or not? Yes, this is also an angle, because for this angle, okay, for this angle, the name of the angle is AOC. AOC. The arms are OA and OC. So your arms are OA and OC. Understood? Similarly, this is also an angle. Suppose this is theta 2 and this is theta 3. This is also an angle, that is theta 3. Sorry, this is theta 4. So whenever two straight lines meet each other, then they form four angles. Okay, theta 1, theta 2, theta 3 and theta 4. Now, as we know, this angle and this angles are vertically opposite angles. So write it, theta 1 and theta 2 are vertical opposite angles, VOA. Now let us consider whether theta 2 and theta 4 are vertically opposite angles or they are not vertically opposite angles. Okay, so for the angle AOC, or you can say theta 2, the vertex is O. Similarly, for the angle theta 4 DOB, the vertex is also 4. DOB, here also the vertex is O. So both the angle for AOC and DOB, they have a common vertex. The first condition is satisfied, right? Next thing, here the arm OA form a straight line with the arm OD. OD is the arm for the angle theta 4, so it is a straight line. Similarly, another ray or another arm OC make another straight line with the ray or with the arm OB. So here two straight lines are made by two non-common arms with the another two angles. Hence, these two angles are also vertically opposite angles. So you can write theta 2 and theta 4 are also vertically opposite angles. So what are the conclusions that we get from this figure? We get a conclusion that whenever two straight lines cross each other, then totally four angles are formed, out of which the two opposite angles are vertical or are vertically opposite angles. So we get two pair of vertically opposite angle. This is first pair, pair means two, right? This is the second pair. Okay, so you can note it down. When two straight lines cross each other, we get how many number of vertical opposite angles? Two pair, right? We get two pair of opposite or vertically opposite angles. This is a simple definition, you can easily remember it. Okay, vertically opposite angles. Here theta 1, theta 3 are vertically opposite, and theta 2 and theta 4 are vertically opposite angles. Okay, now let us take some examples. Suppose there are two straight lines. Okay, there are two straight lines. They will meet each other at a point, suppose O. Okay, so how many angles are formed? 4 angles are formed. 1, 2, 3, 4. This angle is suppose theta 1, this is theta 2, this is theta 3, and this is theta 4. Now could you say which two angles are vertically opposite angles? See, angle theta 1, here the vertex is O. Angle theta 3, here also the vertex is O. First condition is satisfied. Next, for this angle theta 1, the arm, suppose this is an arm, suppose this is M, N, O, P, right? So the arm OM form a straight line with the arm, suppose this is Q, okay? Okay, the arm OM form a straight line with the arm OQ. So this is a straight line. Similarly, this arm ON form another straight line with the arm OP. Hence, theta 1 and theta 3 are two vertically opposite angles. Similarly, you can prove for theta 2 and theta 4, they are also vertically opposite angles because they have a common vertex, and the other two arms form two straight lines with another two arms of the second angles, theta 4. So here also theta 1 and theta 3 are vertically opposite angle, and theta 2 and theta 4 are two vertically opposite angles. Okay? One more example we can take. Suppose the two straight lines meet each other like this. Okay, they meet each other like this. At a point O. This is A, this is B, this is C, this is D. So first tell me which two angles are vertically opposite angles. This angle and this angles are vertically opposite angles. Similarly, this angles and this angles are vertically opposite angles. And you know the reason. The reason is that they have a common vertex, and the two arms form two straight lines with the another two arms of the second angle. Understood? So finally we come to the first theorem of this exercise, that is theorem number 6.1. As I have told you, a theorem is not a self-proven statement. We need to prove it with the help of axioms and postulates. Similarly, we are going to prove this theorem with the help of axioms and postulates. But before that, we have to understand the statement that is given in the theorem. So let us start with the first theorem of this chapter, that is theorem number 6.1. So the statement of the theorem number 6.1 gives that if two lines intersect each other, right, then vertical opposite angles are equal. So we have to understand the statement clearly. So the statement gives that there are two lines, okay, and they intersect each other. Suppose we have two lines like this, line AB and another line CD. So the two lines AB and CD intersect, means meet each other at a common point. Suppose this point is O. Then tell me, how many angles are formed here? Here 4 angles are formed. 1, 2, 3 and 4. Suppose this angle is theta 1, this is theta 2, this is theta 3 and this is theta 4. So whenever two straight lines intersect each other, then 4 angles are formed, out of which two pair of angles are vertical opposite angles, as I have already taught you. So here this angle and this angles are vertically opposite angles. So you can write theta 1 and theta 3 are vertically opposite angles. And I have told you the reason. The reason is that they have a common vertex, and the two other arms form two straight lines with these two arms of the second angle. Similarly, this angle theta 2 and this angle theta 4 are also vertically opposite angles. So write theta 2 and theta 4 are vertically opposite angles. So this is the statement. Okay, this is given in the theorem number 6.1. Now you have to prove that their vertically opposite angles are equal. It means you have to prove these two vertical angles are equal, and you have to prove these two vertical angles are also equal. So you have to prove these two statements. You have already given that two lines intersect each other, then two pair of vertical angles are formed. So you have to only prove these vertically opposite angles are equal. Understood? So let us prove the statement. Okay. So before proving the statement, you have to first write what is given in the theorem number 6.1. So let us write the statement. Okay. So given. What is given? It is given that there are two lines and both the lines intersect each other. So write two lines AB and CD. You can take any lines, okay? Two lines AB and CD intersect each other at a point O. Okay? So construct these two lines. Okay? AB and CD. So they meet each other at a point O. Right? Then, how many angles are formed? 4 angles are formed. Or you can write two pair of opposite angles are formed. Then, two pair of vertically opposite angles are formed. Understood? So write those vertically opposite angles. Now, this angle and this angles are vertically opposite angles. So BOC and AOD. Okay. Similarly, the other pair are AOC and BOD. Okay. So these two pairs are vertically opposite angles, and these all statements are given in the theorem. So first write what is given. Understood? So the next thing is you have to write what need to be proved. Okay, what need to be proved. To prove, this is the exact procedure of proving a theorem, right? So to prove, this is given. Next is to prove. We have to prove the pair of vertically opposite angles are equal. So you have to prove first BOC is equal to AOD. This angle is equal to this angle. You need to prove it. And the second thing, you have to prove this angle AOC is equal to this angle BOD. Okay. So these are the two statements that you need to prove. Okay, this is the figure. Now we will prove how these two vertical opposite angles are equal. Okay, so prove. See, if two angles, okay, meet each other at a given point. Okay, suppose this is a straight line. Suppose this is a straight line, and on this straight line, this is a ray which stands on the straight line like this. Suppose this is a straight line, right? And on this straight line, this is a ray. According to the axiom number 6.1, if on a straight line a ray lies, then the two angles formed are known as linear pair angles. Suppose this is a straight line, and on this straight line another ray stands, then the two angles formed are known as linear pair angles. So similarly, it is a straight line, okay, and on this line this is a ray. So two angles are formed. Now these two angles are known as linear pair angles. Understood? Now compare this diagram with this diagram. Here AB is a straight line, and on this straight line OC is a ray which stands on it, right? So write it. AB is a straight line, okay, on which OC ray stands. Understood? Now, two angles are formed. This is an angle and this is an angle. These two angles are known as linear pair angles, and you know the sum of two linear pair angles is 180 degree. So you can write BOC plus COA or AOC, okay, is equal to 180 degree. Why? You have to write the reason here. Since BOC and AOC are linear pair angles. Or you can directly write since axiom 6.1, because axiom 6.1 tells you the same thing. But it tells if there is a line and another ray stands on it, then the two pair of linear pair or two linear pair angles sum is equal to 180 degree. Okay, so this is the first equation, equation number 1. Right. Next thing, see, CD is also a straight line or not? Yes, CD is also a straight line, and on this straight line OA is a ray which stands on this line. So write it. CD is also a straight line, okay, on which OA is a ray, on which OA ray stands. Okay, so this is a straight line on which this is a ray. So how many angles are formed? 1, 2. Two angles are formed. Now these two angles are known as linear pair angles, and you know the sum of the two linear pair angles is equal to 180 degree. So you can write this angle, okay, plus this angle is equal to 180 degree. So COA, or you can write AOC, okay. So AOC plus this angle AOD is equal to 180 degree. What is the reason? The reason is these two lines or two angles are linear pair angles, or you can directly write axiom 6.1. Okay, now this is the equation number 2. Okay, next, now you have to compare these two equations. You see these two equations. This equation has two sides. One is LHS and one is RHS. And this equation has also two sides. One is LHS and one is RHS. Now you can see that RHS of both the equations are equal. Okay, the RHS are equal. So you can write the LHS are also equal. Okay, if for two equations, any one side are equal, then other side also equal. For example, if 2x plus 3 is equal to 90, this is an equation, and x minus 5 is equal to 90, this is another equation. Now from this equation the RHS are equal, so you can write their LHS 2x plus 3 is equal to x minus 5. So similarly here also their RHS are equal, so you can write their LHS must be equal. So write, compare equation 1 and 2, we get, what we get? We get their LHS are equal. So BOC plus AOC is equal to AOC plus AOD. Understood? So if the RHS of two equations are equal, then their LHS must be equal. Now you can see this also has two sides, LHS and RHS. And in LHS there is an angle AOC. And in RHS there is also another angle AOC. Now what we will do next? Next, we will have to take this angle to the left hand side so that AOC and AOC will be cancelled out. See how it is doing. So write BOC plus AOC. Now this AOC should be taken to the left hand side. So it will be minus AOC is equal to AOD. Okay. Now this AOC and AOC has been cancelled out. Why? Because when 5 is subtracted from 5, then what we get? We get 0. That means same thing is subtracted from the same thing, then you will get 0. So this 2 can be cancelled out. So finally what you get BOC is equal to AOD. Okay, so we get BOC is equal to AOD. Then what is BOC? This angle is BOC, this angle. What is AOD? AOD, this is AOD. Now these two angles are also vertically opposite angles, and what we prove? We prove that two vertical angles are equal. That needs to be proved. This is the first statement. See, BOC is equal to AOD. We have to prove it, and we finally proved it. That the two vertically opposite angles or the one pair of vertically opposite angles are equal. BOC is equal to AOD. This is the first proof. Okay, so proof of statement 1. Right. So next we will prove the second statement. So now we will prove for the second statement, that is AOC. That means AOC, this angle is equal to BOD. BOD. We have to prove this angle is equal to this angle. That means these two vertically opposite angles are equal. We have to prove it. Here also we should follow the same procedure as we followed in statement number 1. Right. So let's prove the second statement. Proof. How can I prove it? See, CD is a straight line or not? Yes, CD is a straight line, and on this straight line OA is a ray. Okay, CD is a straight line, and on this line OA is a ray. Right. So write it. CD is a straight line and OA ray stands on it. Then according to the axiom number 6.1, these two angles are known as linear pair angles. So the sum of these two angles must be equal to 180 degree. So you can write AOC angle plus AOD angle is equal to 180 degree. The reason is, as these two angles are linear pair angles, so the sum of these two angles is equal to 180 degree, or simply you can write due to the axiom number 6.1. Understood? This is equation 1. Next, so suppose AB is also a straight line or not? Yes, AB is also a straight line. Okay, so write it. AB is a straight line. AB is a straight line, and on this straight line OD is a ray which stands on this straight line. Okay, this is a straight line and this is a ray which stands on it, and OD stands on it. So if AB is a straight line and OD is a ray which stands on it, then we have two angles. Then these two angles are known as linear pair angles. So the sum of these two linear pair angles is equal to 180 degree. So write AOD plus BOD is equal to 180 degree. It is because axiom number 6.1. This is equation 2. Now let us compare these two equations. In this two equation, equation 1 and equation 2, you can see their right hand side are equal, 180 degree. Hence we can write that their LHS must be equal. So by comparing equation 1 and 2, we get their LHS must be equal. So AOC plus AOD is equal to AOD plus BOD. Now what can we do next? See, in the LHS side you have an angle AOD and in the LHS side you have an angle AOD. So this AOD should be taken to the left hand side so that these two can be easily cancelled out. So AOC plus AOD and this AOD taken to left, AOD minus is equal to BOD, right? Next AOD can be cancelled out. So finally what you find? We find AOC is equal to BOD, right? AOC means AOC, this angle is equal to BOD, these two angles are vertical opposite angles or not? Yes, they are vertical opposite angles, and we prove these two vertical opposite angles are equal. This is the second statement and we prove it. Understood? So in this way you can prove that the vertically opposite angles formed whenever two straight lines intersect each other are equal.